you. Thank you for having me up here today. I guess what I'd like to do is share kind of what I've done in the last few years, but basically go through a year of seeding the cover crop and kind of sharing what experiences I've had with that. Also some of the other practices that I've incorporated. As was mentioned, the NRCS because of the watershed that I'm in, the Boone River watershed is a target, or was a targeted area, is a targeted area for water quality improvement. And the Mississippi River Basin Initiative is a federal program that the goal is to try to reduce hypoxia in the Gulf of Mexico, which, you know, the Minnesota, Iowa, Indiana, Illinois, you know, we all drain into that all the way down, all the states down to the Gulf of Mexico. But the I-states are probably the primary source of a lot of the nitrates and phosphorus. So they've selected certain areas, certain watersheds that they've identified that trying to show benefit. The Boone River watershed that I'm in is about 550,000 acres, but it's about 88% row crop. And with that comes, in our part of the state, it's highly tiled because of the wet soils. It takes tile to be productive. I assume that's somewhat the case in this area too. In parts of Minnesota, you know, you put tile in the ground, it helps your yields because it's better drained. But obviously that also has led to problems with nitrates going through the tile lines into the streams, into the rivers, down in the Gulf of Mexico. And I don't know if any of you have heard in the news in the last few weeks about this issue with the Des Moines Water Works. Has been concerned about the nitrates that they have to take out of their city water, and they brought a suit against, or going to bring a suit against 3 counties in Iowa that they feel is the source of that, or one source. And I may, if I have time, maybe discuss a little bit about that. But obviously you're on a lake right here. Water quality is very important in Minnesota, as in many parts of the country. It's a recreation thing for Minnesota. It's quality of life. You know, as farmers, we have to be concerned about that, I guess. And some of the things I can show you, I think today, will demonstrate how cover crops can help improve water quality, along with the tillage practices and nutrient management and different things like that. One of the practices I installed was a wood chip bioreactor, and I've got a few slides on that, which is a practice that edge of field practice that can help reduce nitrates going into streams. So with that, I'll get started here. Oops, find the right button. Shut it off, turn it on, okay. This is the watershed area. I'm located right there. We're up about right here. So I'm pretty much 90 miles straight north and just a little bit west. I'm about 30 miles west of Interstate 35. This is the Boone River watershed, which drains into the Des Moines River, which affects Des Moines. The area that's the 3 counties that are getting sued are right in through here in the Raccoon River, which goes towards Des Moines. One thing with cover crops, I guess, is change. You know, we think about the changes that have taken place in agriculture in the last 10 years, 20 years, 30 years, 40 years, 50 years, you name it, there's been change. What was kind of interesting, I was at a meeting yesterday, and he was, one of the speakers was talking about how he is, he puts a round baler, pulls it behind his combine, and all the corn residue, the corn cobs and the husks are collected and put in that round baler because he uses them for his cattle operation. But I got to thinking after I pulled this slide up, here's my cobs and here's the residues all right there. You know, at one point we did save it, but then we generally burned up the husk and maybe used the cobs in a feedlot for bedding or that type of thing. But this was probably 50 plus years ago. This was about the early 70s. My dad decided to sell the moldboard plow. Now, most of you remember that was a tillage of choice up until 30 or 40 years ago. Maybe there's some areas that still utilize that, but obviously no residue on the surface. It's all being buried. The big issue then was wind erosion. You know, the spring's winds would come along and the dust would blow and the soil would blow, and the windowsills in my folks' house was covered with silt, you know, because it just was everywhere. It wasn't like the 1930s Depression era where the Dust Bowl, but yet we still had wind erosion issues. But selling the plow was one method of, our goal was to alleviate that. But I remember when a neighbor bought the plow, he said, "How are you going to farm without a plow?" You know, that was a pretty basic tool. But this was our next step, was just a simple straight shanked spring shank chisel plow that we used in the corn stalks to do tillage, but we left a lot more residue on the surface. And obviously that evolved to the disc chisel, and it's, you know, it's evolved even more into where it levels on the back, and it's really quite sophisticated what can be done now. But you see the evolution that took place. Well, here's where I'm at now. Obviously quite a different place from 40 years ago where we covered everything up. Now we're trying to leave as much as we can and manage that residue. But cover crops is an important part of that for several reasons. You know, we've got the conservation on top of the soil. We've got what's going on below the soil. But one of the purposes that I'm utilizing cover crops is for the nutrient management and the nitrate reduction in tile water. And this is the first, it's a short clip here. If I'll get it to go, and I might not get it to go. There we go. Well, that's what it looks like to stand in a field when the cover crop's being seeded. Cereal rye on dry ground, and you think, how's that ever going to grow? But a little bit of rain, half-inch of rain, and it does grow quite well. I generally seed about a bushel an acre. That's kind of the rule of thumb through NRCS recommendations. Sometimes more is better. A little more cost sometimes involved, but I guess that's what I've used the last 4 years. This past year I did seed some other species, but I'm going to kind of focus on the cereal rye initially here. Airplane, you can see that's basically where it comes out. It just, even though that's only about 4 foot wide, it does spread about 60 feet with the airstream the time it hits the ground. It's not too complicated. Another method that I used some this year was ground seeding, and we did this in soybeans. If you're familiar with Hagie sprayers, are built about 10 miles from me. But anyway, they take their tank off and they put on a Gandy dry box, and that's got a fan system on it which blows through the hoses and drops down below the canopy. And we're doing some studies comparing that to aerial seeding and some different things, but there are some advantages to this. Maybe a little more uniform seeding. In a case of corn, you get below the canopy so you don't have some of that seed that's trapped in the leaves and so forth. But just another way to do it. In 2012, drought year, our crop was matured about 2 weeks early. I decided not to use the aerial seeding since the ground was so dry, and then I actually waited until after I harvested and had the co-op seed my rye with a fertilizer spreader, with a floater. So that worked well too, but obviously things were a little bit earlier that year, and that worked out pretty well. Just a little bit what it looks like on the ground. I think it's around 20 seeds per square foot. Give you is about a bushel an acre. You know, obviously it's not a uniform spread. Some areas you may not quite have that, and some areas have a little more. You have to realize with an airplane flying 120 miles an hour, probably 100 feet in the air, you know, it's not as uniform as a grain drill might be, you know, as you're dropping it in a row. And just simply what it looks like, I guess, after things start growing. It looks pretty spindly, and you think, is that ever going to mount anything? But next spring, that'll be a nice stand of cover crop in my fields. And it's never been an issue with harvest. Obviously, it's pretty spindly and it just lays over, so soybeans, it's never really affected, interfered with harvesting. Just another shot of it. What I found amazing, and I saw this probably in 2013, I went out there after the plane had flown the seed on, and I was looking for it. And I had to scratch around under the residue to find it. And I don't know, people talk about mice and things like that, and I think there is some predation where the mice will come out and eat it, but it does work its way down below the residue. I have, you can see the corn stalks, and you know, there's a fair amount of residue on the surface, but I could pull that stalks away and see the rye underneath sprouting. So it does find its way to the bottom. And don't ask me how. I guess gravity is the... And this is in the cornfield, and kind of a similar situation. Sometimes it almost seems as it comes up better in the corn, probably because there is a little less residue. I notice sometimes along the plant base you don't see it because I think the corn leaves do affect the pattern before it hits the ground. So sometimes you'll see a little bit more in between the rows as you do in the row. And that would be one advantage of using a ground seeding where you could get it down below that. The ground seeding does offer a lot better distribution, I think, in corn especially. This is in the spring 2012. This would have been my first year, I guess. You can see the strips in there, the strip tillage. When I strip tilled in the fall, I had a pretty good, the growth was going good, and I thought, you know, am I going to wreck this by going out and strip tilling it? But in reality, I did not. It really filled in quite well. I've got a few other pictures where you can't even see the strips. They actually, it filled in. But this is where I'm going to be planting my corn in these darker strips. I use an 8-row 30 strip till bar, and then I plant 16-row 30. Even though it's not matched up with the auto steering and so forth, that works pretty well. I found that the planter will slide right in those strips. It's kind of the least resistance, and you can be driving and turn around and look back, and that planter is just centered itself in those strip areas. And I guess, as been mentioned, it's all about the roots. You know, with cover crops, one of the advantages is helping to get the soil tilth improved. And I think with the strip tillage or no-till, cover crops help enhance that because they're helping your soil tilth. You're not doing the mechanical tillage, and having that biological tillage, so to speak, I think is a real benefit. I wasn't necessarily trying to get the biggest handful of roots there, but I did just pull a few pieces out. I think I'm going to have to go out and get some better pictures and get a shovel maybe, and as was mentioned, a shovel is a good thing when you're using cover crops. If you want to see what's going on out in your fields, take a spade out there and just turn some soil over, and you can see it pretty fast what's taking place there. But that root system is very fibrous. It does go down very deep. when you pull it out like this, a lot of the fine ones that are there don't obviously come up with the handful of roots. But all these microorganisms everybody talks about are feeding on these roots. So the better growth you can have out there, fall and spring, early spring, you're just enhancing what's going on in your fields. This is that same field from a different direction, but as you can see, it's a little harder to see the strips in there. This was in some corn stalks that soybeans were going to be planted to. I did try some no-till. This I did not strip till in this small area. I did about 20 acres just trying that. And actually I'm doing some strip trials, side-by-side comparisons is what I mean to say, with no-till and strip-till for soybean planting into corn stalks that I'm established this past fall, and I'll be planting into them this spring. But we'll see in a few more pictures, the stalks actually almost get covered up by the height of the cover crop. This particular year, I think I let it get about 10, 12 inches tall, the rye, before I sprayed it. Just another angle of that. I guess the line there is when it starts warming up in the spring, meaning warming up meaning when the frost goes out, cereal rye will start greening up and start growing. We had some warm days this past week, and along my driveway I've got the cereal rye cover crop, and I was actually seeing some green, and I don't know if it's left over. I thought it all turned brown, you know, things froze, but there was a few spots where where the snow had melted off where it was greened again. So it grows fast. If this is the first, if you're considering cover crop, or if you seeded some last fall and this is your first year, it does grow pretty fast when it warms up, so you want to be ready with your sprayer as far as the termination is concerned. In corn, you know, it can turn from your friend to your foe pretty fast. So where I used to get my planter out the first thing every spring, now I get my sprayer out the first thing every spring. And your days are a little bit limited in terms of temperature. You want to wait till the air temperature is 50 degrees or better if you're going to use glyphosate to terminate your cereal rye, and it takes longer for it to die. It's not like in June or July when you spray glyphosate on a weed, it dies in a couple days. Well, this I found it took a full 2 weeks. After 10 days, I wondered if I was going to have to respray it again. But we talked a little, it's been mentioned about economics, and I guess I'm going to approach the economic side of things a little bit different. I like what Dave did. I mean, he's showing you bushels and dollars, but I've got maybe some intangibles that I think are important. We took some biomass samples and through Practical Farmers of Iowa, and the NRCS came out and they just physically clipped off square foot areas and bagged that up, and it was calculated that there was about 800 pounds of biomass, which is not a lot necessarily, but this is only 8 to 10 inches tall. But we sent those to a laboratory, and that was analyzed, and that 800 pounds contained just a little over 30 pounds of acre of nitrogen. And in 2012, nitrogen was about 50 cents a pound. It's a little bit cheaper. It's cheaper than that now, but you know, it's about $15 an acre. So I spend about $30 an acre putting a cereal rye cover crop out there. So part of that is recouped in the nutrients that are saved in the field. And as Dave mentioned, that's not all available right away. And I'm not sure how much of it is available, you know, at different times of season. It varies so much on the species. It varies on the stage of growth. It varies on, you know, just a lot of things. What the growing season is like, even how it breaks down and how it's utilized by the crop, the cash crop. But that is a determining factor. It is a factor in the economic side of things. You know, we're saving nutrients, and in this case, the nitrogen. A little bit about the spraying. I guess I mentioned that about the daytime temperatures being 50 degrees or warmer. If it's too cool, your glyphosate's not going to activate. It's not going to work. It is going to be slower to die. Now this is the same spot where I think my first slide that showed the strip till strips. You can hardly see them there. And this was 10 days after, and I used 30 ounces of glyphosate. And you want to follow all the rules. You want to use the right amount of water, the right pressures, and all these type of things. Follow the label. You know, it's not a place to take shortcuts. And as I mentioned, is it dead yet? And this was 10 days, and I thought, you know, I was prepared to go out and spray a second time. I did talk to some other people that had more experience with it, and they sent back some texts and said, wait 3 more days. So I waited 3 more days, and in fact, it was all brown. Here I'm planting about 2 weeks after I sprayed it in the strips. About all I did on my planter, I put floating row cleaners on my planter, was about my only modification for planting on the strip. And I guess this is my neighbor's field. I think that was field cultivated twice. But you can see the difference in, obviously, the residue in terms of soil conservation. In 2013, we had too much rain. There was a 10-day period where I had a 3-inch rain, a 4-inch rain, and a 5-inch rain in 10 days. Now, that has an adverse effect, obviously, on tilled soil, where I felt pretty comfortable with having some protection out there between the crop residue and the cereal rye as a soil protector. I guess this kind of shows the row cleaners. I had fixed ones on before, and I just bought these. I think Yetter makes them. Number of companies make floating row cleaners. They're pretty simple, but you never will gouge out. It just floats long enough to move that residue out of the row, if there is some in there. Here I actually no-tilled into soybeans, but you can see where the rye is just kind of wilted down. There's still protection there. There's still plant material there, but it didn't interfere with my planting at all.
You're planting soybeans there?
Yeah, that was planting soybeans, yes.
Do you move your rows every year then, back and forth? You go between those 3
Yes,
years?
yeah. And when I'm planting corn, following soybean stubble, I plant in the soybean row, and then planting soybeans, I just move it over. Some people just move it a little bit. Some people center. I try to center it, but I guess, but again, you see the amount of residue out there, and I mentioned 2013 we had all that rain. Well, 2014, I think we had a 2-week period again with about 13 inches of rain. So, you know, I don't know what the weather is going to bring from year to year. I know Dr. Elwin Taylor at Iowa State and others have mentioned about a period of weather extremes. And obviously we've seen those weather extremes. You've seen them here too with the prevented plant areas that we just couldn't get in the fields. If those things continue, these type of practices are even more important in terms of soil conservation.
Are you strip tilling soybeans there or corn?
I'm planting soybeans into the corn stalks.
Is that stripped or?
Yes. Yeah, that was stripped. It's maybe a little harder to see there, but I put on my strip till machine, I put these same type row cleaners on to move the residue. I've done it both ways. I mean, I'm still kind of learning, but it's not. If you can get a little soil over a soybean plant or a soybean seed, it grows. So, yes, sir.
Now, when you strip for soybeans, you put down any potash or anything? Or?
I'm not. One of the things I'll get to a little bit later about the nutrient management, the grid sampling, making sure you have good soil tests and you know where you're at. So my P&K levels are probably more in the optimum level, so I don't really see a lot of benefit in getting, putting fertilizer on that side, but I know people have done that, depending on what your soil tests are. So, I do apply P and K with my strip till bar that's going to be corn. And I've got a few slides with that a little bit later. This is just a shot, I think, from last spring, but obviously you can see the cereal rye. That's soybean stubble, and that's the corn there. Some soybeans coming up in the corn stalks. This is the other practice that I've been involved with the NRCS. One of the, it's just called nutrient management. But I've gone from applying my nitrogen for the corn, from doing it in the fall to doing it in the spring or side dressing. Also, one of the tools is a late spring nitrate test. You know, soil sampling for nitrogen, essentially what you're doing to see if how much nitrogen is in the soil. Obviously, there's no need to apply it if you have an adequate amount. Or the other thing the test will help you determine is how much more you need to add. We've done tissue sampling. Do that about V10 prior to tasseling, just to kind of see what the plant has. One thing with tissue sampling, it's what it is that day. It varies from week to week to week. You know, it's just kind of a moving target, but it does give you an idea of what's going on out in your field. One thing I learned, and that something I could do something about, was sulfur. You know, they've cleaned all the sulfur out of the diesel fuel, and now we have to add it back to our soils because sulfur enhances the usage of nitrogen in the corn plant. So sulfur is very important. But and then obviously the grid sampling, just doing soil tests, making sure you're confident what you have out there in your fields as far as nutrients are concerned. Another thing I do is late summer stalk nitrate tests. That just helps you determine where you've been. It's not necessarily where you're going, because that's basically after the corn plant is matured. It's after black layer time. They take probably an 8-inch section of stalk, a foot off the ground, and take about 10 or 12 of those for one sample, and it gives you a nitrate reading. And I do that with the Iowa Soybean Association. And then the fellow here is taking, I got a tile right there behind there, but taking water samples, and Iowa Soybean Association has a laboratory in their facility that they can test nitrate levels. So we did that on a weekly basis. I've got some graphs, a few slides later, to show you what I learned with that. And then part of the nutrient management practice is simply having a written plan. And that describes soil types, slopes, fertility, cropping systems, fertilizer you put on, just a lot of different things, but it's kind of a handy tool to use. Another tool I think is real important, and I don't know if you may be familiar with this, but this is on Iowa State University's website and extension, but it's a corn nitrogen rate calculator, or the MRTN, and it helps you determine what is the most profitable amount of nitrogen to apply to a crop, a corn crop. And it takes into account the price of the nitrogen, the price of corn, and you can see that I did this a few years ago. But there, and you can move these around. You can cheapen the nitrogen up. You can cheapen the value of the corn up. But there's a sweet spot there. This is just a larger graph of the same slide, but this is return to nitrogen, dollars per acre. This is your rate from 0 to 250 pounds of nitrogen. The blue line represents the gross return to nitrogen, and the red line, I believe, is the net return to nitrogen. And this is your fertilizer cost right here. You know, we can put more fertilizer on, and we can get better yields, but is it going to give us more income? And that's kind of the bottom line here, and the goal is to be in that zone there, and that's about $1 per acre return. I think it says it's within $1 for maximum return to nitrogen. but that's about a 10 pound per acre range in that blue zone. Now when corn was $5.75, it was or 140 pounds per acre. Now that corn is $3.75, it's probably more in the 130 to 140 pounds of nitrogen per acre. But again, just another tool you can use. Part of this goal of reducing nitrates in the water, Iowa has a nutrient reduction strategy. Illinois, I think, has just adopted one. I'm sure Minnesota will be involved with one in the future, but it's science-based practices that are shown to reduce nutrients in the water supply in the streams. And this is one of the tools that's used in that strategy. This was the 2012 year. It's just an ear of corn, but with 15 inches of water of rainfall that year, I thought, well, I had about 170 bushels an acre it yielded. I was pretty happy with that, you know, with the temperatures we had and the lack of rainfall, and we just, you know, it was just a real uncertainty what we were going to end up with as far as the corn crop was concerned. This slide is taken where those earlier slides where the field was really green with a cover crop. This is pretty much the same vantage point. And that's the soybeans in the same year. You can still see the stalks laying there. But again, one of my goals in doing all this is to protect the soil on my farm. Here's a little better slide of the strip till. It gives you a very mellow zone of soil. Even though I've tilled that with a strip till pass, it's green back up. Some of the seed that might have been disturbed, that rye is still, it's growing back in there. But, and this was seeded with a floater, I guess. This was the year I used ground seeding. A little better picture of, well, this would be in the corn stalks again, but. And this was late November when I took this slide. Still green. The ground hadn't froze up yet, but it slows down in its growth, but it does keep growing. And even though there may not be a lot of growth on top, it's still going down. The roots are still going down below. And then just a handful of soil there, I guess, is, you know, we kind of take it for granted. You know, our topsoil, it's, but where's a farmer without topsoil? Or farm, or land to farm, but you know, that's the most important part, is right there in the top foot. You know, that's where our nutrients are, that's where our plant starts growing and everything. And then I guess the other one is our other resource that we think about and sometimes we take for granted is our water. And this tile hadn't had any flow on it for about 9 months, and then in the spring of 2012, I think from March to April, we had about 8 inches of rain. So I had about half my rainfall in that time period. The rest of it came from planting time through the end of the season when I had that 15 inches that I mentioned earlier. But you know, how important is water? You know, but unfortunately, a lot of times we take it for granted. But as I learned, that water had some nitrates in it. So you know, I've come to realize that there are some things I can do to help prevent that. Now, this is some of the data that I collected from the sampling. Now these points are actually upstream from where I live and downstream. This is time here from March to December, and this is nitrate levels from 0 to 30. EPA's number, it's kind of their magic number, is 10 milligrams per liter or 10 parts per million, which is considered safe or unsafe. Most municipalities probably get that down to 0.05. They get it way down. If there are nitrates in the water, they can take some of them out, or if they have well water. This was 2011. In 2010, I fall applied my nitrogen, and I did not have a cover crop. I didn't start my MRBI program till about in here, but there was no cover crop applied, and there was no there was fall nitrogen applied. And these red dots are my farm. So I was at the high side. I'm actually above what the stream was in my nitrate levels leaving the farm from that one tile that I had in the slide earlier. In 2011, I seeded a cover crop in here, and I delayed my nitrogen application till the following spring or side dress. And here's where my nitrate levels fell that year in 2012. So the stream levels kept going up in that particular year, and they vary from, you know, season to season, month to month. But my high was about half of what the high was in the stream. The nitrates start flowing when the water starts flowing, essentially. When your tiles start flowing, the nitrates are starting to move. The nitrogen is moving through the soil profile. And as the season progresses, this ground warms up, that conversion takes place, nitrogen moves. And the more rain you get, nitrogen moves. So again, I put a fall cover crop on, did not apply my nitrogen. And this is the time frame I installed my bioreactor right in here in September of 2012. And 2013, the stream levels went up even higher. They peaked around 30. And mine went up just a little bit, but again, stayed way below what the stream was. And the stream was essentially the farmers upstream and downstream for me. The Boone River is what the Eagle Creek drains into. That's the stream that goes through my farm. And that's down by Webster City, Iowa. But again, I think it demonstrates some of the benefits, at least in terms of the nutrient reduction in nitrates. And this is where the bioreactor came in. The bioreactors will reduce nitrates anywhere from 30 to 70%. So a 40 to 50% reduction is a pretty good number to use if you have a wood chip bioreactor on a tile line. There is quite a bit of benefit of that. But mine, it took a few weeks for it to get going. My first levels were kind of high, but once the bacteria start working on the nitrogen in that water, the reduction takes place pretty fast. The wood chip serves as a carbon source for the bacteria. So the bacteria live on those wood chips. And then as that water flows through there, the water absorbs up into there's about 4 foot of wood chips in the bioreactor. But they convert that nitrate to nitrogen. And the nitrogen just seeps up through the soil back into the atmosphere. This is, the U.S. Geological Survey has about 15 real-time nitrate sampling stations across Iowa, and one of those happens to be on the Boone River south of me about 25 miles. And this was in 2013. This followed a drought year, and everybody predicted that, soil scientists predicted that the nitrate levels are going to go up because it was not utilized by the corn crop because of the drought. One reason. But as you can see in March, not much going on. The ice starts to melt, levels start going up. Now this is in nitrates, this is in tons per day. Okay. You know, we talk about milligrams per liter. That's like in a can of pop, there's what, 30 grams of milligrams of caffeine. You think, well, how can that add up to tons? But at these stations, they measure the height of the water, the temperature of the water, and the flow. So they're calculating flow in cubic feet per second, and they put in the nitrate level and they calculate that out. But at its peak, it was over 500 ton per day. The day before it was 490, and the day after it was 490, but it peaked out about right there, and it dropped down into July. Rainfall diminished, and obviously it flushed a lot of it. This is a 30-year rainfall average, this dark line, and this was in 2014. You can see where the wet periods came in. This is above normal rain, right, anything above that line. So from mid-June all the way through the end of August and even into September, you know, we had above average rainfall. And this next one is the nitrate. The brown area, gray area is the nitrate levels. This is the stream rainfall amounts, and this is the nitrate levels. And this is over 5 million pounds at the end of August. I've got another chart which I didn't include. It's up to about 8 million pounds by the end of November. The nitrate levels actually peaked in 2014 at the end of the year, which is very uncommon. The peak usually comes in the summertime, but last year, you know, just a few months ago, or a month ago, it actually peaked right at the end of the year. And that kind of leads into the Des Moines Water Works. You know, they're following this just as close as anybody, and they were taking samples from these 3 counties all summer long. But and all you have to do is stand on a bridge and throw a little collection bottle over, and they take those samples to the lab and they can test them. But so they were tracking that all summer long. But and that's what really tipped them over the edge, I think, when they had to run their nitrate removal system in the wintertime. But
what are they doing with the nitrates they take out?
It goes back in the river.
Yeah.
Well, and that's all EPA allows them to do, because that's the reasoning is there. It was there to begin with. Now they're not. There's a lot of water flowing past the Des Moines Water Works in the river, and they're just taking a small amount of that out. But yeah, you think they're going all that trouble to take it out. Why can't they do something with it? But it's kind of a slurry. I think they may even use a salt or something in the process. It would be nice if it could be utilized like, you know, sometimes slurry lime is used from water treatments, you know, and they use it to soften water in some cities and stuff. But anyway, yeah, it goes back. So, and this is I don't put the chart up there because it's too hard to read, but these 9 watersheds, whoops, I backed up there. Those USGS real-time nitrate sampling stations are on these different watersheds. And I mentioned how much was going by this one. Well, they told, I've got a spreadsheet, but it was 1,671 tons a day from April 1st to July 3rd. Now that's, you think, well, that's, you know, at 50 cents a pound, that dollar's up pretty fast too. It was 157,000 tons in that 93 days. And in 2013, at 50 cents a pound, that's $157 million. So when you talk economics, you know, we lose something, we don't necessarily, you know, something we don't see. Now in my watershed that I'm in, this one here, you know, I was part of that. But that calculated about 37 pounds of nitrogen per watershed acre. So when you think in terms of using cover crops, can I keep some of that nitrogen back on the farm? You know, cover crops, cereal rye in particular, as a scavenger, nitrogen scavenger, is a good one to help do that. In terms of water quality, you know, living by a lake, you know, people that boat on that lake, swim in that lake, fish in that lake, water quality is very important. This next slide is an hydrous plant. It's about 30 miles from me. I went on the internet and found their production. It was in 2008, I think, and they've revamped it and updated it. But it produced 1,200 tons of anhydrous a day, which calculates out in terms of nitrogen. 82% of that is about 902 tons. But those 9 watersheds were losing 1,670 tons. And there's no correlation between that plant and the loss, other than that plant, if it was producing, couldn't keep up with what was being lost. I guess that's my point there. But this is a stream that flows through my farm. This is a little bit upstream, but this is a kind of a normal flow, and this is after big rain. And you all know what that looks like. You get too much water in a short amount of time. You've got water in the fields, you've got stream banks overflowing and so forth. This was a road that I don't think I'd ever seen flood like that, but that was after I don't even know how much rainfall that had. But the point there is we're getting more rainfalls with higher amounts. You know, that's the point. In terms of soil erosion, when do you think it happens? It doesn't happen now. You know, granted, we get some black snow, and that's not good. But this is even worse. And this is across the road from me to my east. He does farm down the slope, not across the slope. The sad part about it, it looks like that every year. But he tills it up, smooths it out, levels it off, it goes away. Not really, but obviously the ditch is right here. There's a culvert over here, and that drains onto my farm, so I'm getting some of his farm, which I guess isn't the worst thing in the world, but I just soon see him keep it. But there is some hope, I guess. That's why I put the rainbow in there. Now I'm under the bioreactor. It's a trench. Mine is 5 foot deep, basically down to your tile line. And it's 10 foot wide, 110 foot long. It holds about 125 cubic yards of wood chips. These control structures are what determine how much water flows in and out. There's rods in there. This is the bottom, this is the top. And there's stop gates in there. And those stop gates, you can add or subtract, and you can control the amount of water that flows through. And that's what helps determine how effective or how much water will flow through the bioreactor. And this is the semi just backing up and then loading the wood chips into the bioreactor. And that kind of gives you a little idea what they look like. They're maybe a couple inches long. They're pretty uniform in size. I know some farmers actually used refuge or branches from a municipality that were chopped up. You know, after a storm, they can chop them up. The issue there is you don't like to have leaves in them. So mine were actually purchased from a wood chip supplier. They specialize in different grades of wood chip, mulching for landscaping, that type of thing. But that's what it looks like. There's about 18 inches or 2 feet below the surface. This fabric is rolled down over that, and then the soil is put back on top of it and just leveled off. You could farm over it, other than the control structures are right there. This happens to be in a filter strip along the stream that goes through the farm. The ditch, drainage ditch is right behind that area. So this was the main drain that used to, and it still does flow into the stream, and then we put a secondary one in here. When there's high flow, high tile flow, it just bypasses. You're not trying to take out nitrates during the peak flows, but over the average flow over a longer span of time. And this is more of just a diagram of what it looks like, but this being the bioreactor, your field tile, a diversion, the water flows through here, goes through here, and while that water is going through, and the length of it helps determine the retention time, and the width of it helps determine the capacity. My bioreactor has about 40 acres of tile flowing through it. It's not pattern tile necessarily, but there's probably a 40-acre area that drains in through there, and it's sized accordingly.
Tim, you want to start taking some questions?
Sure. I'm going to just mention this real quick. This is a kind of a new practice, and it's something that you can get some NRCS program through. And this would be used in an area where you might use a terrace or on a side slope on a field that you're concerned about soil erosion. But this concept was developed at Iowa State here just a few years ago. And this first one was put in the Neil Smith National Wildlife Refuge west of Des Moines. I don't know how many thousands of acres it is, but they do have some cropland there. But essentially what you're doing is putting a narrow strip 20 to 40 feet wide of prairie species, maybe 5 or 6 grass species, and the rest being forbs, perhaps up to 30 different species. And the goal there is to reduce several things. Reduce soil erosion, catch nutrients, and it's also a tremendous wildlife habitat area. But they replicated these different checks. This one is none, this one just has it at the base. This one has it at the base in 2 areas, and this one has, I think it's 20%, this is 10% in these different blocks. But this was actually no-till corn, but you can see the amount of soil after heavy rain that went through there, and these, they call them H-flumes. They also measure the nutrient loss in the soil and the water. This is with the prairie strip, 10% prairie, 90% crops. The water is a lot clearer, a lot less sediment after this rain event. And obviously with 100% prairie, your water is clean. There's no soil moving with 100% prairie. But it does demonstrate the benefit, and this is no-till. But they call this disproportional benefits because there are so many benefits for just taking out a little bit of land out of production. Another area, they're counting the species. They seeded 33 in this particular plot, but they actually found 39. And I'm not sure why that was, but I think there's probably some native things in the soil, perhaps, that came up. Not positive on that. And I think the reason for the extra ground cover is because of they take into account the height. It's not just the area of the ground that's covered, but it's also the height. So that's one of the benefits. The other one, obviously, is the wildlife, the bird life. They measured 52 bird species, 11 were nesting, twice the abundance of wildlife with the prairie strips as compared to just row crop. And then the pollinators, the insect diversity was a tremendous amount. There's, I think in future years, going to be a lot of attention focused on this. Monarch butterflies, I guess, is almost being considered for the endangered species. And this would be a tremendous amount of benefit to monarch butterflies. You put a few milkweed species out there, and I guess that's what that's going to be. But anyway, and I think these are the practices for the NRCS people in here. And I'm doing this on my farm using a contour buffer strip. I already have filter strips by the stream, but I am putting this 30 species mix in my filter strip also. And if you want some information on it, those are some folks to talk to. But the Walton Family Foundation sponsored this, the McKnight Foundation there in Minneapolis, I think, USDA, SARE, FSA, I don't know, I can't read them all, Forest Service, this is IDALS and Iowa State and Leopold Center, but they all help support this project. There's about 20 landowners and farmers that are seeding this year, and their goal obviously is to see it grow even more. And I just wanted to mention it because there might be some areas up here that might be adaptable for some of your farms. And I guess I'm going to end with this. You know, you think about water quality, you know, it's not just about farms and farmers, but, and I don't know if that was, what do they call that, whoops, they put that, Photoshop, there you go. But anyway, they're all going for a ride and they're having a good time, but you know, we got to think about future generations too when we think about conservation. It's not just here and now, it's how are we going to leave it? Is it going to be better than what we started out with? But I think using these practices, you know, we can help accomplish that. So.
Thanks, Tim.